So the first question that is given to us is, it says light travels a distance x in time t1 in air. So x distance it travels in time t1. If distance is given, time is given, we can calculate the speed. So velocity of light in air can be written as x by t1, and 10x in time t, this is t2, please, this is t2, there is a error is there printing. So velocity in denser medium, it is your 10x by t2, 2 is missing over there, it will be your t2. Okay, in denser medium, what is the critical angle for this medium? Now what is a critical angle? First of all, let us understand, whenever light travels from denser to rarer medium, and when light travels from denser to rarer medium and the angle of refraction in rarer medium is 90 degree, then the angle of incidence in denser medium is termed as your critical angle. What is our formula for critical angle? Sin theta critical is given as mu r by mu d, that is your refractive index in rarer by refractive index in denser. Do we know mu r by mu d? No, directly not given, but it is given to us, speeds are given to us, or speed we calculated earlier, right? We know that refractive index is your c by v. So mu r by mu d, mu r by mu d can be written as what? Mu r by mu d, as you can see, refractive index inversely proportional to speed, so we can write mu r by mu d will be vd by vr, right? Speed in denser medium by speed in rarer medium. How much is your speed in denser medium? It is 10x by t2, and speed in rarer medium, that is your x by t1. X cancels out, that means 10 t1 by t2. This is what is ratio coming for mu r by mu d. This is the ratio. Let's substitute over here. So sin theta critical is equals to mu r by mu d, that is 10 t1 by t2. So theta critical will come out to be sin inverse of 10 t1 by t2, right? You can check the option, which option it is. Option number 3. Option number 3 is our correct answer. Let's look at next question. Yeah, our question says two thin lenses are of same focal length f, but one is convex and other is concave when they are placed in contact with each other. So convex lens and another is concave lens, both are having focal length ff only, you know, and the equivalent focal length of the combination is, how do we write down equivalent focal length when lenses are combined? So 1 by f equivalent is equals to 1 by f1 plus 1 by f2. Important thing, this, the focal length must be put with sign convention. For convex lens, focal length is positive. For concave lens, focal length is negative. So 1 by f minus 1 by f. So 1 by f equivalent, 1 by f equivalent, if you will notice, comes out to be 0. 1 by f equivalent is 0. That implies f equivalent is infinite, right? So infinite is our answer, which is option number 3. Yeah. So the question that we have is, in the figure shown, what is the equivalent focal length of combination of lenses, right? I have drawn it for me. So over here, if you will notice, these are thin lenses basically, although the figure is appearing as if that these are thick lenses, but these are thin. According to the question, we have to consider thin lenses which are combined. So let's say that the focal length of this is f1. This is your what? This is your plano-concave lens. This is f2, which is your biconvex lens, and this is again plano-concave, which is your focal length f3. What is our equivalent focal length? Equivalent focal length 1 by f equivalent is 1 by f1 plus 1 by f2 plus 1 by f3, right? First of all, let us calculate individual focal length. So for this first one, our lens maker's formula say 1 by f is equals to mu minus 1, 1 by r1. Lens maker's formula mu minus 1, 1 by r1 minus 1 by r2. This is our relation. Lens maker's formula visible to you guys? No? This mu minus 1, 1 by r1 minus 1 by r2. This is our lens maker's formula. Now it's visible. So first of all, let us calculate focal length of this one. 1 by f1 will be equals to mu minus 1, that is your 1.6 minus 1, 1 by r1. R1, If you notice, this is plano concave. So this one is your plane surface, the focal length r1, the radius of curvature for this one will be your infinite. R2 will be your basically positive, and how much it is your minus of r1 r2 both are given to us 20, so this will be your minus 20. How much are we getting over here? This is 1.6 minus 1, that is your 0.6. So minus 0.6 by 20, which we will be getting over here minus 3 by 100 centimeter. Fine. 1 by f1 value we got it as minus 3 by 100. Let us calculate. So this is my f1. 1 by f2. f2 is your this biconvex length, so it will come out to be mu minus 1, 1.5 minus 1, 1 by r1 and r2. R1 is 20 centimeter, R2 is also 20 centimeter. So it will come out to be your 1 by 20 minus of minus, because this value we will be taking when you will consider like this, light ray is coming in this manner. So R1 sign will be taken positive, whereas R2 sign will be taken negative. This lens makers formula is applied with sign convention. So R1 minus of minus 20. How much are we getting? 1.5 minus 1, this is your 0.5, that is 1 by 2 into 1 by 20 plus 1 by 20, that is your 2 by 20. How much are we getting? 1 by 20 centimeter. Well and good. This is our focal length. Second one is coming 20, or 1 by f2 is 1 by 20 centimeter. Fine. Let us calculate 1 by f3. 1 by f3, again this is your plano concave lens. Mu minus 1, that is 1.6 minus 1, 1 by r1. R, see over here, radius of curvature. How much is our radius of curvature? Radius of curvature for this one is, this is again 20, and it will be negative. If you notice carefully, like this it will be coming, right? So for this one, third one, the radius of curvature will be coming negative. So minus 20 minus of 1 by r, this one, plane surface, that means your radius of curvature will be infinite. So 1 by infinite, which is your 0, and 1 by infinite is 0. So how much we are getting? 0.6 into minus 1 by 20. How much again we will be getting? Minus of this will be 0.3 by 100, sorry, 3 by 100, hai na? Yes, 3 by 100 will be getting, minus 3 by 100 will be your 1 by f3. Well and good. This is our f1 minus 3 by 100, f2 1 by 20, and your f1 by f3 is minus 1 by minus 3 by 100. Let us solve it. Spacing 1 by f equivalent is equals to minus 3 by 100 plus 1 by 20, right? Minus 3 by 100, right? This one I can write it as minus 6 by 100 plus this will be 5, we can multiply it, so this will become plus 5 by 100. Minus 6 by 100 plus 5 by 100, that means it will come out to be minus 1 by 100. So 1 by f equivalent is minus 1 by 100. So f equivalent is minus 100 centimeter, right? Some calculation was there, but yes, we got our answer, minus 100 centimeter. That means option number 2. Yeah. So the question we have is, a light ray falls on a glass surface of refractive index root 3 at an angle of 60 degree. Okay, let's consider this is your glass surface or a glass slab, we can take it, and angle of incidence is given to us is 60 degree. Fine. They are asking the angle between the refracted and reflected ray would be. Fine. What will happen over here? If you notice, light is going from rarer to denser medium, that means it will bend towards the normal. It will bend towards the normal, and this is our angle of refraction. Okay. Also, some part of light will get reflected. Angle of incidence is equals to angle of reflection. So this angle will also be 60 degrees. Okay. Can we find out this R, that is angle of refraction? Yes. With the help of Snell's law, we can write mu1 sin I is equals to mu2 sin R. Mu1 over here air, sin I, angle of incidence is sin 60, that will be your root 3 by 2. Mu2, refractive index of for this one is root 3 into sin R, right? Root 3 cancel, sin R value comes out to be 1 by 2. Sin R is 1 by 2, that implies R value is 30 degree. We got R as 30 degree. So this angle is 30 degree coming. this is 60, this is 30, 90, right? And total angle we know is your total will be your how much? 180. 180 from this is 60, this is 30, 90. That means how much is the angle between, this is your refracted ray. I hope it's visible, red color to you guys. This is your refracted ray and this is your reflected ray. So the angle is 90 degree, and angle between reflected and refracted is 90 degrees. Yeah. Next, we have a theoretical question. Let us see. During a cloudy day, a primary and a secondary rainbow may be created. Which of the following statement is correct? Now, primary rainbow and secondary rainbow. Primary rainbow and secondary rainbow, first of all, they are formed due to your total internal reflection. What is the difference? Difference is in secondary rainbow, total internal reflection, TIR, will take place 2 times, right? In a water molecule or in a water bubble, basically your TIR will take 2 times. So now if you will check the option number 3 will come over here. In option number 3, correct information is given. Secondary rainbow is due to double internal reflection, that is your double total internal reflection, and it is formed above the primary one. So third option is our correct answer, right? Theoretical factual question it is. We have to keep the factual information in mind. That is your purely NCERT based. Fine, let us move ahead. Yeah. Question given to us is, a biconvex lens has radii of curvature 20 centimeter each. If the refractive index of material is 1.5, the power of the lens is. What is our power of lens? Power of lens is basically 1 by f in meter. And power of lens 1 by f in meter. Can we calculate your focal length? Both of them are given to us. Radius of curvature as 20 centimeter, and this is your refractive index is 1.5. Let us calculate our focal length using lens maker's formula. 1 by f is equals to mu minus 1 by r1 minus 1 by r2. r1 is, this is your r1 and this is your r2. According to sign convention, if the light ray moves like this, that means we consider light going from left. According to sign convention, r1 will be positive and r2 will be negative. We need to be careful with sign convention. So mu minus 1, that is your 1.5 minus 1, that is 0.5. 0.5 r1 and r2 magnitude wise same, but sign convention will be different. So this will be 1 by 20 minus of minus 20. Fine. So this will come out 1 by 2 into 2 by 20. So 1 by f value is coming out to be 1 by 20. This is in centimeter. This is in centimeter. We are getting focal length is coming in centimeter, right? 20 centimeter. To find out power, so what can I write it? Power is equals to 1 by f in meter. So we will get over here, this is your 20 centimeter, so we can write it as 100 by 20. We will get it 5 diopter. So our power is 5 diopter plus 5d, which is your option number 2. Yeah, so we have question, two transparent media A and B are separated by a plane boundary. Fine. A and B. The speed of light in those media are 1.5 into 10 power 8 and 2 into 10 power 8. So over here speed is 1.5 into 10 power 8. Over here it is 2 into 10 power 8. Well and good. The critical angle for a ray of light for these two medium is. Now, first of all, from where to where can we calculate refractive index? We can calculate refractive index. Refractive index of A. Refractive index of A will be C by V, right? It will be C by V. If we calculate 3 into 10 power 8 divided by speed in A, which is given to us 1.5 into 10 power 8. That comes out to be 2 times. So refractive index of A is 2. Similarly, we can calculate refractive index of B, which is your 3 into 10 power 8 divided by 2 into 10 power 8, which comes out 1.5, right? A is denser. Refractive index of A is 2. Refractive index of B is 1.5. A is denser, B is rarer. That means for TIR or for critical angle, the light ray must go from denser to rarer. It should go from denser to rarer because this one is denser. So this should be incident and this will be your refracted, and angle of refraction should be equals to 90 degree. This is your denser medium and this is your rarer medium. We could have also seen less is the speed, more refractive index. That way also we can see, but we have calculated our this also. Fine. What is our sin theta critical? Sin theta critical is given as refractive index of rarer by refractive index in denser. So sin theta critical is equals to mu r. What is our mu r? That is your refractive index of B, 1.5 by mu d. Mu d is our denser medium, refractive index is 2. How much are we getting? This will come out, sin theta critical is 3 times 4 times 3 by 4. Sin theta critical is 3 by 4, 3 by 4 is 0.75. This is 0.75. That implies theta critical is sin inverse of 0.75, right? Sin inverse of 0.75, option number 1. Yeah. Next question. It is there in front of you. I have drawn the figure over here and you also have the question. So what is given to us is a convex lens is there, biconvex lens, focal length 30 centimeter, a plane mirror is placed at 40 centimeter in front of it. A object is there at 60 centimeter in front of the lens. Now this is a question of combination of lens and mirror. One by one we will deal with it, right? And we have to follow your light ray. Light ray means basically this is the object, light will be first of all falling on like this. Okay, light will be falling on the lens. So first what will happen? First will be your basically refraction at lens will take place. First is refraction at lens. First is refraction at lens. Let us see. So light ray falling, u, how much is object distance? 60. F is 30. You can calculate by lens formula or directly also from our image formation. We know that if object is at 2f, image also forms at 2f only, because this is 60, focal length is your 30, that means object is at 2f. So image will be forming at 2f. That means from here this refracted rays will be going at a distance of 60 from the lens. That means somewhere like this. These are your refracted rays from the lens. So it is like this. Actually they will obviously not be able to go past the mirror. So rays were supposed to go at a distance of 60 centimeter, but in between what has come? Plane mirror has come. So for plane mirror, this I am calling this is now your what? Image I1. This is our first image due to the refraction at lens. How I took it? 60 2f 2f, it will be 60. But in between what has happened? A plane mirror has come. Now for this plane mirror, these rays will act as incident rays. And for this incident rays, this I1, that means this I1 will act as an object for the plane mirror. How much is the distance? This distance is your 20 centimeter, right? This is 60, total is 60, so 40 plus 20, so 20 centimeter is our I1 distance. Okay. Now, this plane mirror will reflect the rays. What is our relation for image in case of plane mirror? Object distance is equals to image distance. This is a virtual object for plane mirror. It will form an image like this, something this way over here. Object distance equals to image distance. These are your reflected rays, and these reflected rays are again falling onto the lens. So second what happens? Second is your reflection. The second phenomena that has taken place is reflection at mirror, and over here your image is coming. This image is your I2. I2, this is the image formed by the plane mirror. At what distance? This distance is your, obviously this is 20. So in case of plane mirror, object distance and image distance are same. So this will also be your 20 centimeter only. Fine, well and good. This is 20. That means from the lens, the distance is again 20. This I2, now these light rays are now, after intersecting over here, they are moving ahead and falling on the lens. So these light rays, these reflected one, are actually acting as incident rays for the lens. What is the object distance? Object distance is 20 centimeter and focal length is 30 centimeter. So third phenomena is, third what is happening while the light rays are returning, we will have refraction at lens, right? Now let us find out our final image. Basically final image will be on the basis of these rays, because once the light rays crosses the lens, there is nothing over here, so that will give us the final image. Let us apply lens formula. 1 by f is equals to 1 by v minus 1 by u. Focal length for this one is 30, it's biconvex, so obviously it will be positive. 1 by V u, object distance, this is our object distance, and according to sign convention, because we are going opposite to incident ray, these are the incident rays in this case now. So opposite to incident ray, that means your object distance will be negative. So minus minus will be plus 20 centimeter. We will get over here 1 by V is equals to 1 by 30 minus 1 by 20. When we will calculate it, 1 by V value will come out to be minus 1 by 60. So V value comes minus 60 centimeter. Now see the interesting thing. This is the distance from lens, but it is coming negative with respect to what? These rays. That means we will have to go opposite to the incident ray for our final image. A virtual image is forming. Because your V value is coming negative, that means it's a virtual image. From the lens, it will be 60 centimeter. 40 plus 20, that means again over here the rays are actually forming. Something like this will happen. They will be, this kind of situation will be arising like this. Okay, little bit figure has got complicated, but step by step I hope you must have got it. So they will basically meet like this. Third one, so V is coming minus 60. So after third refraction, V is minus 60. Minus means with respect to this lens, the image will be forming, it will be virtual, and from lens it is 60. That means from mirror it will be 20 centimeter. Right, now check the option which it is. Option number 4, 20 centimeter from the plane mirror, it will be a virtual image. In these type of question, deal with them one by one. Just start with the light ray going, passing through optical element, lens, mirror, and then again while returning you are through lens. That's why first refraction, then reflection, then refraction, and finally then we got our answer, right? I hope you understood it. Let's move to the next question. Yeah. So the question that is given to us is again a combination question. This is a combination of lens and lens. Previous question we did, that was combination of lens and mirror. Now this is lens and lens. What we have? Two lenses are there, convex lens and concave lens. Focal length is 20 centimeter and 5 centimeters, separated by a distance of d. I have drawn the figure, right? They are asking if a parallel beam of light falling on A leaves B as a parallel beam, then the distance d in centimeter is. Fine. That means if a light ray falls parallelly on this one, and after refraction over here, it leaves your concave lens in parallel, then what should be your distance d? What do we understand about your parallel rays? What is interaction? So basically, if a convex lens is there, if parallel incident rays are there, after refraction, they will pass through the focus. Right? And we also know that if, let's say, this is your concave lens is there. Concave lens, when does light ray refract parallel to the principal axis? Basically when the light ray is appearing to pass through focus. When it is appearing to pass through focus, so after refraction it will go parallel to the principal axis. That implies one thing is there. This is your parallel incident ray. So after refraction, it must pass through focus. Focus of this one, how much distance it is? 20 centimeter. 20 centimeter. And if light rays are coming parallel, that means the incident ray for this one must be passing or appearing to pass through your what? Focus of this one. Focus of this one is where? Focus of this is at 5 centimeter. In this side, it will be over here. 5 centimeter. Okay, well and good. First of all, light will refract. They will refract like this, they will refract like this, and they should appear to pass through the focus of this one, appear to pass through the focus of second one, and therefore I am redrawing this one, two figures. Okay, so these are first refraction. They should pass, the refracted rays should fall at a distance of 20 centimeter, and for your concave lens, they should appear to pass through focus. That implies then they will be going parallel, like this situation will appear. Now you can see over here basically what it will be. This total distance is how much? 20 centimeter. Why 20 centimeter? Because incident rays, parallel incident rays, after refraction they will pass through the focus. Focus of this one will be at 20 centimeter. This is 20. So these refracted rays are falling at 20, but for concave lens it is at 5 centimeter. That implies this d value will come out how much? D value will come out 15 centimeter, right? So just by ray diagram also we have dealt with this question, right? Only with ray diagram and understanding of the nature of light ray through convex lens and concave lens. D value will 15 centimeter. Let's move ahead. Yeah. So the next question that is given to us is, find the value of angle of emergence from the prism. Refractive index of glass is √3. Fine. So I have drawn the figure. This is what is given to us. This is our incident ray. How is incident ray falling? Incident ray is falling normally. We know whenever your normal incidence is there, your angle of refraction will also be 90. So it will pass undeviated. Undeviated means this will be your refracted ray, hai na? So refracted ray, it will fall onto this vertical surface. Can we calculate the angle of incidence? Let us see. If this angle is your 60 degree, this is 90, that implies this angle is your 30 degrees. If this is 30, this is again 90, 30, 60, that means this is your again 60 degree, right? I hope it's okay. If this is 60, this total is 90, that implies your this is 30 degree. Angle of incidence at the second surface is coming out to be 30 degree. Now let us apply our Snell's law at this surface. Mu1 sin I is equals to mu2 sin R, right? Mu1 refractive index of the prism is given √3. Sin I is sin 30, that is 1/2 is equals to mu2. Outside obviously it's air into sin R. So how much we are getting? √3/2 is equals to sin R. That implies R is 60 degree. So it's coming from denser to rarer, so it will be something like this. This angle will come 60 degrees. So our angle of emergence means the angle with which the light ray is coming out. The angle with which light ray is coming out. In this case, it is your 60 degree. We calculated. So this, and R you call it, or E. Basically, this is angle of refraction at the second surface, which is also our angle of emergence. Fine. So which option it is given? Option number 1. Option number 1 is our correct answer. Yeah. Next, we have a mirror question. It says, an object is placed on the principal axis of a concave mirror at a distance of 1.5 f. Concave mirror. This is our concave mirror, focal length f, and object is placed at 1.5 f, right? They are asking us the image position. Right? Fine. Let us see. Mirror formula. What is our mirror formula? 1 by f is equals to 1 by v plus 1 by u. With sign convention we have to put. Concave mirror is basically focal length is negative, so it will be minus 1 by f is equals to 1 by v. Object distance, it is opposite to incident ray, that means we will take it object distance negative. Minus 1.5 f is basically your 3 by 2 f, so u value comes out to be 2 by 3 f. When we simplify it, 1 by v is equals to 2 by 3 f minus of 1 by f, 3, 1 by v value comes out minus 1 by 3f. So v value is coming minus 3f. V negative because the image will be forming in front of the mirror only, and distance is basically 3f. You can see the option. Negative sign is also given, so we have to take sign also. A and B sign is also given, so B option will be there. Minus 3f will be our answer. Yeah. Our next question is, a ray of light is incident at an angle of incidence I on one surface of a small angle prism. Fine. Let us consider a prism is there, small angle. So let's take it as angle of prism as A. Okay, and this is a small angle given to us. Fine. Next it says, and emerges normally from the opposite surface. Over here basically it is coming normally. It's coming out. Angle of emergence is 0 degree. Emerges normally, angle of emergence will be 0 degrees. So if it is emerging normally, that means over here this angle of incidence at the second surface, for this one R2 value, if you remember the derivation for your prism, R2 value will come out to be 0. Fine. Next it says, if the refractive index of the material of prism is mu, the angle of incidence is nearly equals to. Fine. This is given to us as mu. We have to find out your angle of incidence. Let's say this is our angle of incidence I. Now R2 is 0. How we got R2 0? R2 0, that means the angle at which it is falling, because it is emerging out normally, that means angle of emergence is 0, so angle of incidence over here will also be 0. If R2 is 0 for prism, what do we know? For prism, the property R1 plus R2 is equals to A. What is R1? Basically, this is your R1, right? R1 plus R2 is equals to A. R2 is 0. That implies R1 is equals to A. Fine. Now, let us apply your Snell's law at the first surface. What can we write? Mu1 sine I is equals to mu2 sine R1. Okay. Mu1, that is air. So, this is 1. Sine I is equals to mu2. Mu2 is refractive index of the prism, which we can write as mu into sine of R1, which is A. Small angle is given, that implies we can write I is equals to mu A. That means for smaller angles, sine theta is equivalent to theta, which is also equivalent to tan theta. In this, it's not required, but in this question, this thing is required. So these terms, sine we have taken as I is equals to mu A, right? This is our answer. Option is option number 4. Yeah, next question. In total internal reflection, when angle of incidence is equals to critical angle for the pair of media in contact, what will be the angle of refraction? So this is basically a theoretical question. Definition of critical angle. In critical angle of refraction in rarer medium should be 90 degrees, hai na? So 90 degrees, option number 4 is our correct answer. Next question. Next question, it is given to us. Two similar thin equiconvex lengths of focal length f each are kept coaxially in contact with each other. Okay. So like this is the situation, right? Two similar thin equiconvex lengths of focal length f each. This is also f, this is also f. Well and good. It says such that focal length of the combination is f1. Right now the combination is f1. What do we know? 1 by f equivalent is equals to 1 by f1 plus 1 by f2. 1 by f equivalent equals to 1 by f1 plus 1 by f2. So 1 by f equivalent is equals to 1 by f1. Both are same. So 1 by f plus 1 by f, that will be 2 by f. So in this case, f equivalent is coming out to be f by 2, which they have given us as f1. Okay. Next it says, when the space is filled between the two lenses is filled with glycerin, between the two lenses is filled with glycerin, which has the same refractive index mu equals to 1.5 as that of glass, then the equivalent focal length is f2. Okay, so now you have this spacing. In this spacing, they have filled basically glycerin, but it is having same refractive index, and the combination of this is giving us your equivalent focal length as f2. So beta, first of all understand, this is your convex, this is convex, and when glycerin will be filled, it will be acting as a concave. So convex, concave, convex, right? This will also be focal length f only. Why focal length f only? Because the refractive index are same and the radius of curvatures are also same, right? The difference will be because these are convex, and this one in the middle one, when we have filled it with your liquid, because this is over here, if you will notice the shape of this will act as a concave. This will act as concave, the one that I have filled over here, right? This will be acting like concave. Magnitude wise it will be f, but with sign it will be coming minus f. Now let us write down f equivalent, which is given to us as your f2. So I am writing 1 by f2 is equals to 1 by f. This one, because it is your concave, so it will be minus 1 by f plus 1 by f. Cancels out. So f2 value comes out to be f. f2 is f. Ratio is asking which ratio, f2 by f1. f1 is to f2. f1 by f2 they are asking. So f1 by f2. Okay, this is f2. f1 is your f by 2 and f2 value is f. It cancels out. Your answer comes out to be 1:2. 1:2. 1:2. Option number 2. Option number 2 is our correct answer. Yeah. So question we have, a double convex lens has focal length of 25 centimeter. Double convex lens, focal length 25 centimeter. The radius of curvature of one of the surfaces is double of the other. So if this is r, this one will be 2r. Any one of them we have to take it. So one is double of another. Fine. Find the radii of curvature of the material of the lens. Refractive index is 1.5. ठीक है, mu value is 1.5. Let us solve it. Lens maker's formula. Let's consider that light ray are coming from here, and this side light ray is coming. So 1 by f is equals to mu minus 1 by r1 minus 1 by r2. 1 by f, it is given to us 25, and for convex lens it will obviously be positive only. So 1 by 25 is equals to mu minus 1.5, that is 3 by 2 minus 1 by r1. Now be careful with the sign convention. R1 is this one which is positive, so it is your 1 by r, and r2 will be negative because this side, if you notice, to measure the radius of curvature, we have to go opposite to incident ray. Therefore, R2 will be negative. Sign convention. So this will come minus of minus 2R. Okay, let's simplify this. So 1 by 25 is equals to 1 by 2 into 2, we will get over here 3 by 2R. Okay, if I further solve it, we will get over here 4R by 3 is equals to 25, right? 4R by 3 is coming 25. Yeah, so R value is 75 by 4. How much can we write it? This one will be your 1 times 15. 15 means sorry, 35, so 18 will come. 18 point 1 minute, 75 by 4. 1 times 3, 35, that means your 8 times, okay, 32, 3, that means 18.4 something will be coming. Do we have answer? Yes, 18.75. 18.75 is our answer, right? Radius is 18.75. It is R, and another is your 2R. Another one is 2R, so you can calculate 18.75 into 2, right? Check your option which we have. 18.75 and 37.5. Third option will be a correct answer.